How is algebra used to build stock investment strategies? Can decisions about future trades be made in the present? Financial engineering is the study of solving complex problems in finance and economics, using mathematics and computers. It often deals with situations in which the conditions of future trades must be set in advance. For example, the price and quantity of goods to be traded 1 year later can be determined now. But why set the terms of a trade before it even happens? The first reason is to reduce risk. By setting future prices and quantities in advance, it becomes possible to stay steady despite unexpected changes and focus on other tasks. Like preparing an umbrella before it rains, financial engineering creates a standard for dealing with an uncertain future. As a result, decisions can be based on calculation rather than vague worry. The second reason is to gain greater profit. If the future can be seen more accurately and decisions can be made more quickly, it becomes possible to stay ahead in competition. However, one point must be addressed. Does knowing mathematics always lead to making money? It does not. Markets always contain unpredictable factors, and many financial transactions are structured so that one person's gain becomes another's loss. Then, what role does mathematics play in this complex financial world? Consider the Black-Scholes equation, often called a magic formula in finance. To understand it, several key concepts are required. Let us look at options, a term often used in the stock market. An option is the right to buy or sell a stock at a fixed price on a specific date. The right to buy is called a call option, and the right to sell is called a put option. The price of an option is not determined by a single factor. It depends on several elements: the current stock price, expectations of future value, the time remaining until expiration, the interest rate, and volatility, which shows how much the price fluctuates. High volatility means large price movements. Another key concept is the risk-free interest rate. It refers to an interest rate that can be earned with almost no risk, as if guaranteed by the government. The concept of the time value of money is also added here. Even with the same amount, $10 today is not equal to $10 a year later. Money held now has greater value because it can be invested immediately. Based on these ideas, in 1973, two economists, Fisher Black and Myron Scholes, developed a formula to calculate option prices. This is the Black-Scholes equation. This equation is built on the concept of Brownian motion. Just as pollen floating on water moves irregularly, stock prices are assumed to change in the same way. The greatest advantage of this formula is its speed and efficiency. Even under complex conditions, it allows the price of an option to be calculated quickly, enabling investors to make faster decisions and act promptly. It also helps explain how the value of an option changes over time. For example, it shows that as the expiration date approaches, the value of the option tends to decline. However, the formula is not perfect. It is based on assumptions that do not fully reflect reality. For example, the assumption that stock prices follow a fixed pattern often fails in real markets. The idea that markets always behave rationally also does not hold in reality. People sometimes hold on to stocks, or even buy more, because of the hope that prices might rise, even when losses seem likely. To what extent, then, can mathematics explain the movement of the stock market? The Black-Scholes equation has its limits, but it remains a powerful tool. This equation has been extended in many ways and is used to price increasingly complex financial products. It is not perfect, but it is one of the most sophisticated attempts to understand an uncertain market.